This lecture, I have to start speaking about the routing on MikroTik. So I'm going to do a lab, but before I do the lab, I just want to explain to you how routing works and what is routing. Because we are working on router OS, that means we have to do routing. So I'm going to give you an idea about what is routing exactly, and then I'm going to come to this lab, which is about 9 points to do, and then we'll do them, and this will make for you clear what is routing on the MikroTik, but again, on the MTCNA level. So this is a very nice diagram that I really like to explain on it what is routing. Let's imagine that we have this autonomous system. So autonomous system number 200. Autonomous system is nothing more than set of equipments, routers, which are under our responsibility. So we are authorized to do whatever we want on those routers. And we have here 5 routers. Let's say there is a network on this router here, and there is a network on this router here. Okay, so the networks means there are PCs which are sitting inside these routers. So let's imagine that one of the PC, which is over here, want to reach to one of the PC which is over there. So we say this is one PC here, and it is one PC here. Then he will send his request to the router, and the router, he has to do routing, because router, he can send it from this way, he can send it from this way, then from this way, he can send it this way, this way, this way, and so forth. So he will decide which is the best way to send the packet, because we're talking about layer 3, and in layer 3 it's called packet. So which the best way to send the packet to be received to the destination, and that's what is routing. So that's the idea of routing. You have to think it's like the router would take a decision in order to be able to send his packet to the destination, because as you can see here on this autonomous system, he can send it via different networks. So he can send it via this router, then this router send it via this one, then they send it via this one, and then it comes to the network. He can send it directly from here to here, and then to the network. He can send it even from here, for example, then from here, and then from here, and then from here, and then from here, and then to this network. So you can see there are different ways, and we as network administrator, we can configure the routing that we decide manually which route to be taken, but also there are some routing protocols that works dynamically. So it will be based on mostly the cost or the bandwidth or the hop counts to be able to reach to the destination. Okay, so that's in brief what is routing. So now we know what is routing. Let's check now what are the different types of routing we have on our network. So we have something we call autonomous system, as I said. So autonomous system means it's a set of routers which are under our privilege that we have to configure them. And inside those autonomous system, we can configure routing. And this can be either the static routes, or also we can use the dynamic route. And those routing, we call them normally interior gateway protocol. Okay, you can see that this is making here to say that this is autonomous system 1 and this is autonomous system the second one, and we can configure inside the autonomous system on those routers. We can configure the routing protocol, which are called interior gateway, and this is something we can make it like RIP. Of course, we are working on MikroTik, so IGRP and EIGRP that are not there because those are for Cisco, but we can also configure OSPF. And then you have also here what is the ISIS, that's an intermediate system. So those are the routing protocols. You can configure them inside the network, okay, inside the autonomous system. There is another routing protocol that you have to configure it between autonomous system, and for this there is only one routing protocol, and it's called BGP. You can see BGP, it's between the autonomous system, and it's called exterior gateway protocol, EGP. So IGP is interior inside the autonomous system, and EGP is exterior. So on BGP, you have to think that the internet is connected via BGP. So ISPs, every ISP has an autonomous system, and they are connected to each other via BGP. And by the way, BGP is a very complicated routing protocol that, of course, if you like to learn it, I also have a course speaking about BGP on MikroTik. Okay, now the type of routings that we have something we call the static route. So static routes, and that's mainly the static and the default route. So we have static route and the default route. Static route means that if I want to say to go to the network which is 192.168.2.0/24, go from this way. So I'm just saying to which network I have to send the packet. So the route is going to that destination. I'm just precising the destination. While default route means that to send to anywhere, send it from this way. And that's normally what we use on the internet, because on the internet we cannot say to go to Google, go from here, to go to Yahoo, go from here, to go to CNN, go from here. So what we say, to go to anywhere, send it from here, and we make the route, and that's what we call the default route. And those are static. It means that we as network administrator, we configure them manually on the MikroTik router. And also we have something we call the dynamic. The dynamic routes, and again, we have seen them here. For example, RIP is dynamic, and it is interior gateway protocol inside the autonomous system. We have, for example, OSPF is also interior. And we have, for example, BGP is exterior gateway protocol. That's between the autonomous system. And those will take decisions by themselves. We only configure them on the MikroTik routers or on any routers that we are working on, and they can take the decision themselves because they have algorithm and they are very smart to take a decision. For example, like I said here, if we have a network here and a network here, and I configure OSPF inside this autonomous system, then this router here will decide which way he has to take, because it's configured OSPF, and then he will check based on the cost, which is also based on the bandwidth. So we don't want to go through that, but that's how the dynamic routing protocol works. So now we understand the different type of routing that we have. For MTCNA, you are responsible for only the static and the default route, and also to have an idea, like I have given you ideas about the dynamic routing protocol. Now let's go back to the points and start doing the lab. Point number 1, put IP addresses as shown on the graph, and the hint to use bridge interfaces for the network. So before I start this point, let me just show you what we need to do here. So we have this network, we have router 1 and we have router 2. There is no any configuration on the routers, nothing. So I just reset them, and we have to start from scratch. And we have network here, which is 1.1.1.1, and network here, which is 2.2.2.2. So we have to think that those are 2 networks from each side of the router. And what I want is that this router at the end to be able to reach the network which is here, and also router 2 to be able to reach this network over here, because at this moment they don't know anything about those networks because it's not in their routing table. So those routers needs to be configured by using the static routes to tell them that if you want to go to that network, go from this side, and you have to say the same thing for router 2. So that's the basic things that we need to do, but of course in the lab I will have some more points to do. So point number 1, put IP addresses as shown on the graph, and hint use bridge interfaces for the networks. So let's put the picture here and let's go to router 1 first. So this is router 1. And on router 1, we have to put the IP addresses. And I will go to IP address. Remember, we have to look to the picture so you can see what I'm doing. So on the interface Ethernet 2, I have to put an IP 192.168.12.1/24. And this is going to be on Ethernet 2. Now, this is one side. And 1.1.1.1, this network, where should we put it? So do we have already a network? So I don't have a network connected. So I will emulate a network using the bridge interface. So here, bridge is not really the bridge that you have already learned in this track. Here, a bridge interface is nothing more than to say that this is a network, because a bridge interface, when you create it, it's a network by itself. So here, I already have this bridge. I will not put any ports here, just a bridge interface, a virtual interface. And I will put on this interface an IP of 1.1.1.1/24, and I will put it on the bridge interface. So this is on the first part. Let's do it on router 2. Now we go to router 2 IP address. I will say 192.168.12.2/24, and this is going to be on Ethernet 2. And then I will create a bridge interface. Also, I have it, no ports inside of it. And then from here, I will say 2.2.2.2/24, and it is on the bridge interface, bridge 1. And that's it. Port number 1 is done. Port number 2, ping from router 1 to router 2 connected interface. Do you have a reply? Then ping to 2.2.2.2, and do you have a reply? Let's try. We go to router 1, and from here I will go to the terminal. I will say ping. My connected interface is 192.168.12.2. This is the interface on router 2, and I have a reply, so that's fine. Now we have to ping to 2.2.2.2, and no route to host. Why? Because if we go here to IP route, look, the router doesn't know anything about 2.2.2.2. He only knows about 192.168.12.0 because he is connected to that interface, and he knows about 1.1.1.0 because he has it on his interface, which is the bridge interface. So he doesn't know about 2.2.2.0, so there is no ping. But I just want to show you something here. Look at this, D, A, and C. So D means dynamic, A means active, C means connected. So because we have put the IP on the interfaces, then he put them on the routing table, and he say that this has been created, this entry, the routing entry, dynamically it has been created, and it's active and connected. So that means we didn't create it manually ourselves, it was dynamically created. Okay, so that's now the point is done. Let's see what we have to do. Port number 2 is done. Port number 3, from router 1, configure a static route to reach to 2.2.2.0, and then we have to do also from router 2, configure static route to reach 1.1.1.0. Okay, so how to make the route, the static route? We have to go here on router 1 to IP, we go to route. And here I'll have to say on route plus, I will say to reach one, actually we have to say to reach 2.2.2.0. That's the destination that the router 1 needs to reach it. So I'm telling router 1 to be able to reach to this network, then send your packets to 192.168.12.2. And what is 192.168.12.2 is the next hop. If we go back to the picture, so I'm saying to router 1, okay, if you want to send your traffic to reach to this network, then send everything to your next hop, and your next hop is 192.168.12.2. Okay, and then I will say okay, so this is from router 1, but we have also to do it from router 2, because also now router 2, he doesn't know how to reach 1.1.1.1. So we have to tell him that to send your data to be able to reach to 1.1.1.1, send everything to your next hop, which is this one. And if you want, we can go to router 2 now, and we go to IP route. And we see on the IP routes, he doesn't know anything about 1.1.1.1. And if you want, we can try to ping 1.1.1.1, and you can see there is no route to host. Now, what I need to do, I have to say here, plus on the route, to reach 1.1.1.1.0, the network, /24, send to your next hop, which is 192.168.12.1. And then I will say enter. Port number 3 is done, and port number 4 is done. Now, from router 2, ping 1.1.1.1 with source address 2.2.2.2. Do you have reply? Let's go to router, this is router 2, yeah. So now, I will go to the terminal, and I will say, I want to ping from router 2 the destination network, which is 1.1.1.1, and I want this ping to come from the loopback that I have, the bridge interface, which is 2.2.2.2. So I'm saying that from my network, I want to see, which is 2.2.2.2, if I can reach 1.1.1.1, because normally on your network you have a PC or something, and that's the one which needs to reach to the destination. And then enter, and here we go. You see, it is working. Why? Because he checked on his routing table. Oh, you want to go to 1.1.1.1? It's on this network. I have this entry that is active and it is static. It's saying to send everything to the next hop, and I will send it to the next hop. Router 1 receive it, and then router 1 send it to the network 1.1.1.1, and then 1.1.1.1 send it back, and then he will say, oh, you want to send it back to 2.2? Yes, it is there. I have it, so I will send it to 2.2.2.2. So that's why it is working. Port number 5 is done. Port number 6, put cable between Ethernet 4 interfaces. So what I'm going to do now, everything is working fine for me now, but what I want is to make another link here between the two routers, and that's going to be on interface Ethernet 4. So I put the cable on Ethernet 4 on both routers, and then I have to do some work. So I will do it and come back. So I have just put the Ethernet 4 cable between them, and this point is done. Port number 7. On Ethernet 4, of router 1, we have to put an IP 192.168.21.1, and on router 2, 192.168.21.2 also on Ethernet 4. So we have just to put IP addresses. Okay, let's do that. So I'll go to IP address, and I will say for Ethernet 4 it's 192.168.21.1/24, and it is on Ethernet 4. Enter. And then also for the router 2, I will say I put an IP address of 192.168.21.2/24, and it is on Ethernet 4. And let's check if they can see each other now on Ethernet 4. So just a simple ping, 192.168.21.1. So that's the interface, the IP which is on Ethernet 4. And then that's fine. So you can see that router 2 is able to see router 1 on the Ethernet 4 interface. Port number 7 is done. Port number 8. Now on router 1 and on router 2, create two static routes to reach the destination network using the new link. So if we go back here to the picture, now what's happening is that we have two links. That means the router 1 can use now this link, because we do the route and we said to send all the traffic to the next hop using this link, right? Now what I need to do also is to say that also router 1 can use this link to reach to the network 2.2.2.2. So I'll point to this next hop. But also on router 2, I can say the same. You can use the first one, but also I will do the second one also route that you can also use the second one as well. So we have to create new static routes, and this time to be used by the second link on both routers. So let's do that. We go to the router 1, and from here I'll say IP routes. And then I will say to reach 2.2.2.2. to 0 here, it should be because it's a network. Then send it to 192.168.21.2. That's his next hop. Okay, so you can see now we have this entry already there, and now this is the second one, and I will say enter. So you can see we have now two entries to the same network, and both of them, they are pointing to the same destination network. Okay, and we will see now which one is the active and which one is not the active. We go back to the second router because we have to do it also from the second router, and from here I will go to IP route. And I have to say to go to 1.1.1.0/24, send it to 192.168.21.1 and enter. And here we go. Also, you can see that you can reach the same network either via Ethernet 2 or via Ethernet 4. All right. So now let's have a look, and we'll see that the main one which is now working is the one which is on Ethernet 4. You can see this is active, and this one is not having an A, so it's not an active. That means it's using now the link of Ethernet 4 on this router, but as well on the second router, it's using the link of Ethernet 4. That means the link on Ethernet 2 is there, the route is there, but it is not active. Okay, port number 8 is done. Port number 9, make the link on Ethernet 2 to be the preferable routing to be used. So everything now is sent via Ethernet 4 on both links. Now they say that we want to make this one to be preferable, the Ethernet 2 on both routers. So how to do that? Actually, if we go inside this one, you have to see you have a distance, administrative distance, that's what we call it. It is by default 1. So this one is 1 here, and also this one is 1. So also on router 2, the same. So what is the administrative distance? Administrative distance is something that you can increase it, and once you increase it, then the route that it's having a higher administrative distance will not be chosen. For example, if we want now that this one, which is on Ethernet 2, to be the one which is chosen, it has a administrative distance of 1. Then we go to this one and we make the administrative distance to be 2 higher. And okay, look what's gonna happen. Directly, Ethernet 4 is being now deactivated, so it's not active, but the one which is on Ethernet 2 becomes active. Let's do also on the router, this is router 2, we do it on router 1. Also, we go to the this one on Ethernet 2, I'll make it, actually I go to this one and I'll make it also distance 2. And now we can see that on both sides, the router 1 and router 2, they are using now Ethernet 2 to send their traffic to each other on the destination networks. Okay, so administrative distance by default is 1 for static. For connected, it is 0. You can check here. The distance of connected is 0. The one which has the lowest administrative distance is the one which the router will prefer it and will use it. Of course, RIP, for example, has 120, or SPF has 110. So you can see that the routing, they always look first for the static route. Before the static route, of course, the connected route. But between all the routes, the static routes is much better than all other dynamic routing protocol. Now, what I can do, I just want to show you how this happens now automatically. If I take out the cable of Ethernet 2, because now all traffic is going from Ethernet 2. And if you want, I can show you here. If I ping 2.2.2.2, and I can ping it also from the source address 1.1.1.1, and you can see the ping is working. So now what I will do, I will take out the cable from Ethernet 2 interface on router 1. So I just unplug it. Look at the routing table, what will happen. So I just took it out. Look directly what happened. The router has one request timed out, but now the traffic is being sent from Ethernet 4. Why? Because it has a distance of 2. It was like working as a backup. Now everything was sent from 2, but 2, the cable is out. You can see now my cable is by my hand. You can see it here. And now what's happening, everything is sent from Ethernet 4. I will put it back now. And let's have a look. You can see now, once I put it back, because it has administrative distance of 1, which is better than 2, then again, it is going via Ethernet 2. Okay, port number 9 is done. And before I finish this lab, I just want to show you also about the default static route, because I said you have static route, you say where to send the packet to which network, and you say I want to reach 2.2.2.0, send it from here. So I'm just saying what is the destination network. But if you have something like the internet, we don't say to which network, we say we want to send it to anywhere. So how to do the default route? If I go back to router 1, There is router 1. I have put on Ethernet 1 the ISP cable, okay? So what I will do now, I'll go to IP DHCP client. And I will say, I want the DHCP client, but do not give me a default route. I just want it to be on Ethernet 1. And then I will say, okay. So now you can see that router 1 has received an IP. And if we say ping now to Google, it's not going to work because there is no route. I say to the DHCP, do not give me route. Now, how can I create the static route, the default static route? All I need to do is to go to IP route. And from here, I will create a new route. And the default static route should be like this, 0.0.0.0/0. So to go to anywhere, send your packet. And then here I have to say what is the next hop. Okay, so in my case, I think the next hop, I'm not sure about it. Let's check IP address. So I think the next hop is 172.22.0.1. So I will write it here. The gateway is 172.22.0.1. And then I will say, okay, apply. Let's see, it's reachable via Ethernet 1. And now if I make ping again to 8.8.8.8, and here we go. You see, I can now go to the internet because I created the route. And if I make, for example, ping to Google, because Google is anywhere, right? It's 0.0.0.0/0 means if you want to reach any network. If you want to ping, for example, hotmail.com, I'm not sure if it's possible to ping it. Normally they block the ping. But if you want to ping, for example, bbc.co.uk, then you can see you can reach any network. So with this, I have just covered everything about routing that you need to know for the NTCNA track. So again, remember what I have discussed about the different type of routing, what is the autonomous system, and also the interior gateway protocol, exterior gateway protocol, the dynamic route, the static route, the default route, and the administrative distance. So all of those, I have put them all in one video. So I hope that this lecture was informative for you, and I'll see you in the upcoming lecture.